Hi guys and welcome back. In this video we're going to be looking at the day 21 project solution. Today we're learning how to plot graphs using Matplotlib in conjunction with learning how to split our code into multiple Python files. So this project is going to be a little bit more complicated than the ones before, but of course that happens every project, they all get more complicated. And today we're going to start off by plotting graphs. And so we'll be using Matplotlib, which means that as you're doing this project, and indeed as you're using any library, you should have the official documentation for Matplotlib open so that you can check it out and maybe read it, try to understand what's going on as you go along. But what we're going to do is we're going to use the pyplot submodule of Matplotlib. So the first thing we're going to do is import it. So we'll do from Matplotlib import pyplot. And that is going to give us the pyplot submodule of Matplotlib. Pyplot has a lot of different functions inside it that allow us to create plots or charts or graphs, depending on how you want to call them. So if you're using REPL-IT like I am here, you should be able to just run this code and it'll work, and it won't do anything at the moment, but you won't get an error. If you are running this yourself in your own computer outside of REPL-IT, then you'll have to install Matplotlib, and we've got an installation guide linked down in the description of this video. So now that we've got pyplot, we can use it to plot a graph. And we're going to do a scatter plot in this video for the project that we're going to be building. So how do we do a scatter plot using Matplotlib? Well, we first of all need to define the x data, which is going to be the values for the scatter plot along the x-axis. And I'm going to do something simple and do 1, 2, 3, 4, 5. And then we need some y data, which I'm going to do something like 5.5, 6.4, 5.3, 4.4, 7.9. It doesn't really matter what value you use, but those are the ones I'm going to come up with here. Then, very simple, we do pyplot.scatter, and that is going to draw a scatter chart or a scatter plot, and we pass in the x data and the y data. Now, if we do this, it's not actually going to display anything. What pyplot is doing behind the scenes is it's generating a new figure or a new sort of place to put this plot. And it's drawing the scatter plot in that hidden place. Then we need to ask pyplot to either display the drawn plot to us, or we have to ask it to export it to a file. Because we're using REPL-IT here, and it doesn't have the capability of displaying the plot to us directly, we're going to export it to a file so that we can then open the file and have a look at the graph. So we'll do pyplot.savefig, just like that, and that means save figure, and that's going to save that place that pyplot has been using to draw the scatter plot into something like graph.png. It's important to use a .png there at the end, as pyplot is going to know how to do this. Now if you press run, you'll see that no output happens, but if you open the Files tab, you'll see that graph.png now exists, and it contains our scatter plot. If you don't see graph.png, refresh your window, as sometimes REPL-IT, or indeed any editor, sometimes bugs out, and it doesn't display the refreshed files. Alright, now that we've got this, we can tell you a little bit more about how to save different figures. Because here we've got this figure, but if we copy this entire thing and paste it again, and now I'm just going to change these values slightly. Just like that. And now I'm going to press run. You'll see that both sets of data, this set and this set, ends up in our file. Notice that we've got the blue dots that are the first few that we drew, and we've got the orange dots that are the second few that we've drawn. And that is because when we tell pyplot to draw a scatter graph, pyplot draws the scatter graph on the figure that it is currently drawing on that area to draw graphs. And by default, it creates one such area and then draws all the graphs on it. Therefore, when we draw this scatter plot, we then export it as a file, that's all good, and then we draw another scatter plot with different data points on top, and we export the file again, this overwrites the old file and we end up with one file with both sets of data. So that's no good. What we want to do is we want to tell pyplot to create different figures every time we create a new scatter plot. Fortunately, that's really easy. All we have to do is say something like figure equal pyplot.figure. And when we run pyplot.figure, that actually creates a new space inside pyplot for drawing graphs. And we can reference it using this variable. So automatically pyplot is going to draw the new scatter graph on this new figure. We don't have to tell it to do that, but we do have to export the figure that we have drawn. So by doing that, we get a new figure and the plot drawn there. Down here we can do the same thing, and now we will get one graph called graph.png that only contains these data points, as you can see. Now, of course, if you went ahead and changed these names, you might end up with two files, and that's totally fine. Now that we know about pyplot, we're going to go ahead and explain the project brief and start tackling it. As usual, though, you can access the project brief down in the description of this video, and I recommend you do that because it contains some data that you may want to copy in order to achieve this project. The data that we're going to use and we're going to plot is going to be something like iris.csv, and it contains the data that we saw back in day 14 where we were looking at files. It's about the flower data for 3 different species of flower. We've got Iris setosa, versicolor, and virginica, and they have different lengths or widths and things like that of their petals. If you're not a flower fanatic like I am, no, just kidding. But if you don't really understand what this means, don't worry too much about it. Later on, we'll show you how you can do this same thing with your own data set if you want. It's really straightforward to change the data after the fact. But we're going to be using this data because it is short enough and varied enough that we'll be able to see some interesting things going on. So I'd recommend creating a file, putting the data in it. Remember, you can access it in the project brief, linked below in the description. And then we can go ahead and look at what we should do. So users should be able to create a scatter plot where the x-axis is the species. So that's, for example, Iris setosa, Iris versicolor, and Iris virginica. Those are going to be at the bottom axis, the x-axis. And in the y-axis, we've got one of these other columns. So either sepal length or sepal width or petal length or petal width. So essentially what we're going to scatter is the column against the species. And that's going to let us see whether there's any relationship between species and one of these columns. Then via a user menu, they should tell us, the user should, what column they want to map against the species. And also they should be able to tell us what we want to name the output file. So notice that I've been calling it graph.png. We're going to let users tell us what they want to name their file. All right, so how are we going to tackle this project? Because clearly it's a bit longer. There's a few different parts that we have to deal with: the file, the graphing, the user input. So how do we start something like this? Well, the first part is to think about those different parts of the project. If they are entirely different, then often you may want to place them in different files. That's just a rule of thumb. It's not necessarily the right way every time. But here we've got 3 distinct parts, and therefore we could create 3 files and start off like that, see how we feel after we started writing some code. And so I'm going to use main.py for my user menu. I'm going to use something like graphs.py for the interaction with pyplot, and I'm going to use data_storage.py for my CSV file interactions. Then I usually like to start with the user menu. You guys already know this, that I like that because it allows me to start thinking about how the user is going to interact with the application. And so what I'm going to do is I'm just going to copy in here some code that is the user menu. So we're going to allow users to choose from the following options. Enter C to chart a new graph, or Q to quit the application, and then we ask them for their selection. Now we're also going to ask them for what column they would like to chart, whether that's column 0, 1, 2, 3, or 4, etc. And so we're also going to have a variable that contains the prompt for that, even though we're not using it just now, but we're going to use it in a moment. Then we can start coding our menu. So we'll say while true, and then we are going to ask the user for their selection. So we'll say user selection equal input of user menu. That's one of the benefits of defining that at the top. We can now just use it and it saves us a bit of time. And then if the user selection is equal to Q, that means that they want to quit. We just break out of the loop. If the user selection is equal to C, that means that they want to do something with charting. So we're going to create a function called handle chart that does all of that for us, whatever that may be. And finally, if it's anything else, we're going to print something like, sorry, but that user selection is not valid. So we'll do that. It's not a valid option. Just like that. So here we've got our menu. Clearly, this function doesn't yet exist, so we're going to go ahead and create it. We'll do handle chart. And what we're going to do in here, just to test that this is all working, we're going to ask the user for their input on the charting menu. So we're going to ask the user what column they'd like to chart, even though we're not going to use it just now. We're just going to run this to test whether it's working. So I pressed play, and then you can see that we've made a mistake down here. I forgot to close my string. That's totally fine. You can try again. And now we get our menu here. We can type C to chart a new graph. Then we can type 3, for example, and then nothing happens because the function doesn't do anything. But it seems the menu is working, so that's great. Now we can continue into the next part of the project. So at this point, you may want to think, what is the next simplest part that I can code that will allow me to make a step forward in coding this project? And for me, that is going to be to draw a chart with hard-coded data when we run this function. The reason for that is because if we go into reading the CSV file, which we could do as an alternative, we're not really going to be able to use the data in the CSV file to draw a chart until we've essentially written all the code that we will need for this application. Whereas we can maybe create a function that draws the chart with some mock data to verify that that part of the application is working. And so I'm going to go ahead into the graphs.py file, and I'm going to import pyplot. So we'll do from Matplotlib import pyplot, and then I'm going to create a function called createChart that takes in an x and y value and simply does pyplot.scatter on x and y and pyplot.savefig graph.png. Notice that here I'm not creating a pyplot figure. I'm not allowing the user to pick their own file name, etc. This is as simple as it can be so that we can move forward, and then we're going to come back and add more stuff as we go along. But for now, we can go back into main.py and call that from here. The first thing we have to do is, of course, import. So we'll do from graphs import create chart, and here we're going to run that. So we'll do create chart, and we're going to just pass in some mock information. So we'll do 1, 2, 3, 4, 5, for example, and something like 5.5, 6.4, 5.3, 4.4, 7.9. Doesn't matter. Just make sure to call this correctly, and now when we run this application, we're going to be able to see whether we can create charts successfully with some data that we pass in. Now I'm going to delete graph.png at the moment so that we can tell that something did happen, and I'm going to run the program. You can see that we've got some, bogus stuff from before, but we're not going to worry about that. It doesn't matter what column we enter either, and then we can exit. And now you can see that graph.png was indeed created, and it's there. All right, so what does this tell us? This tells us that if we can get the data from the user, we're going to be able to draw a chart with it. So the next and final step is to actually get that data from the user. So how are we going to do that? Well, we can begin by going over to datastorage.py, and we're going to create a function called readColumn that is going to take a column number, and it's going to essentially read all the data from one column. Notice that we can't do this all that easily, because normally the way we read files is line by line. And we're not really interested in line by line because a line contains a lot of different pieces of data. We want, for example, all the sepal lengths and all the species, and then we can map one against the other. That is why we're going to go column by column instead of row by row. So how we'll do that is we'll say column data is equal to an empty list, and then we're going to open the file, read through it, and append to that. So we'll do with open iris.csv in read mode as something like iris, and then we'll do for line in iris.readLines. And now we're going to use slicing to skip the first one, since the first one contains the headings and we're not interested in those. Then we will say data equal line strip split on the comma, and we will say column data dot append, And what we're going to append is from the split data, whatever column the user was interested in. So if they're interested in column 2, for example, then we will append data 2. So we'll say append data with the number, and then we're going to use that. Notice that we're not doing any sort of validation here. If the user chooses a number that's too large, we're going to get an error here, but we're not going to worry about that just now. You can fix that later on with error handling, as you've already learned if you want. Finally, once we've populated that, we'll return column data. Now, this is probably not the most optimal and efficient way of doing this, because if we want to read the species and one other column at the same time, we're going to have to open the file twice and read through it twice, which is probably not the most efficient way, but it is very easy. And sometimes that is going to trump efficiency, certainly with smaller applications like these. Now we go into main.py and we're going to import the function we created. So we'll do from data storage, import read column. And now the benefit of this is for the x-axis, we can read a column which is the species. So that's the last column. And so we'll go to main.py and we can say read column -1. Remember that when we index into a negative number, so in data storage, that -1 is going to be number, and then we're going to do data -1, that's going to start counting from the end of data. So -1 is going to give us the last element of data, which is going to be the species in this case. Now, then we go back into main.py, and for the other value, we'll do read column, and we will use the column that the user gave us. So that is going to allow us to now read those two columns and pass them as x and y. As you can see, very straightforward when you start thinking of the data as columns instead of just rows. Let's run this and see what happens. I'm going to enter C and now column 0, for example, and then Q to exit. Now we've got a new file here that we can access, but as you can see, it looks a little bit weird. Why? Well, 5.1, for example, is down here, followed by 4.9, but then you've got 5.5 up here, which doesn't make any sense. Surely this should be from like small numbers up to large numbers. And also this data looks very suspicious. So the problem is that when we are reading the data that we want to put into the y-axis, and we're going into here and we're reading that and appending it to column data, of course, everything that we're reading and appending is a string. That's because when we read a line, that's a string, and then we split it, we still get strings, the appended, then we append it, and we still get strings in there. So we're actually graphing strings against strings, and pyplot can't make any inferences about, what's a low value and what's a high value for the axes. So instead what we're going to do is we're going to turn these into floats. So we'll do float of n for n in read column. And that is going to use a list comprehension to turn every element of this collection into a float. Now, I think this is getting a little bit long, so I would normally put these into separate variables. So I will do x is that, y is this, and then map those two like that. I think this is a little bit easier to read. All right, so now we're turning those into floats. We can try to run this again, but actually I'm going to stop that, open this first and clear it so that you guys stop seeing all that old data there. And now we can run this and see what happens. So I'll enter C, and then we're going to map column 0. Then we're going to quit. Now we'll open graph.png, and this data, although still looks a little bit suspicious, but I'll explain why in a moment, now starts to make a bit more sense. The low numbers are on the left, the high numbers are on the right, and we can start to make some distinction between the species. Clearly, Iris setosa seems to have much smaller numbers, and the other two have slightly higher numbers, so that's an interesting thing. This data looks weird because we've only got 3 values on the x-axis, so it's always going to look like, a bunch of dots in a straight line. If the values here were continuous, like they are on the y-axis, then you would see a much nicer distribution. But of course, we've got discrete data here, 3 specific values, so they're always going to look like that. If you had a lot more values, then you would start to see some more interesting things as well. Something interesting to note is that there's only 4 points here for Iris virginica, even though there's 5 for both of the others, and we know there are 5 rows in the file. That's because two of them are just one on top of the other. You can see 6.3 here, 6.3 there. And so what we can do is we can go over to graphs.py and we can add a new value to scatter, a new parameter, that's alpha, and we're going to give it 0.5. That's going to make the dots partially transparent. So if we run this again, you'll now see that the dots are partially transparent. We can see them a little bit better when there's two, one on top of each other. So I'll open the graph again. Now you can see that most of these are partially transparent, but this one clearly has some more data there, one on top of the other. That's why it's more opaque. Now, going back to the idea of creating multiple figures that we discussed earlier on, I'll show you what happens when we try to chart multiple graphs. So we'll chart column 0, for example, then we'll chart column 3, and then we'll quit. And then you'll see that when we do graph.png here, you've got the data from column 0 in blue, and then we've got the data from column 3 here in orange as well. This doesn't make any sense because we're essentially plotting two entirely different sets of values into the same axis, and that is senseless in statistics. So what we have to do, of course, is we have to create a new figure for each set of values. And we already know how to do that. We can go over to graphs.py, and in here we'll do figure equal pyplot.figure, and then we will spell it correctly, and we will save that. Remember that when we create a figure like this, pyplot automatically selects it and starts drawing on top of this new figure. It doesn't use the old figures anymore, although you could, if you wanted to keep track of old figures, you can do that, and then you can, draw more things on old figures if you wanted to. I don't know why you'd want to do that, but it's something that you can do. And then we're going to save it down here, and notice that the name is still graph.png. But that's going to now work. So finally, the last part is to allow users to name the output file. So that's pretty straightforward. We already know how to ask the users for a string, and then we can just pass it in and use that as a file name. So right here, we're going to go ahead and ask the users for the string that they want to name the file. First of all, though, we will create a file name prompt that asks the user, what they'd like the file to be called. So we'll say enter your desired file name, and we'll use that down here. Just like that. And then we will pass it over to create chart. Of course, create chart has to accept it as a parameter as well, and then we can use it instead of graph.png. Something we may want to do is we want to strip the input, so you can do file name.strip in here if you want, or you can put it at the end of the input prompt. Either, it's up to you. Something that users might do if you allow them to simply give you the entire file name is they might do something like, graph.txt. And you can't save an image into a txt file, so the best thing to do is to go back to graphs.py, and here use an f-string to put the file name .png. That is going to make sure that whatever the user enters, we're always going to save it as a PNG, save us some trouble down the line. So that's it. Now we can run this project. We're going to clear this first, though. Let me run that again. And now we will be able to chart multiple columns, for example, 0 into something like, what's it called? sepal length.png, and then we can chart, for example, C, and then column 1 into sepal width.png, and then we can see those two different charts, how different they look, and how the different species are different in these specific measurements. So that's everything for this project. This was a substantially trickier and more complicated project than the ones we tackled before, but you can see now that we are actually, creating proper complicated applications. We're graphing stuff, we've got multiple files, we're using data, and it's all really awesome, and we can do a lot of stuff with this. I would recommend that you check out the pyplot documentation, which can be difficult to read, I'll give you that, but it's going to allow you to draw things like bar charts or, line charts, etc., if you're interested in other types of graph. Also, remember that pyplot, if you are coding outside of REPL-IT, can, make a window pop up and show you the graph. It doesn't always have to save it to a file. It can do a lot of other stuff as well. So I hope you were able to work through some of this project yourself and give it a bit of thought. The thing that matters the most is that you gave it a good go, and then we can help you, with the last few things here through this video. I'm also going to leave a link down below to the final code that you can check out. And remember that if you want an extra challenge, you can tell users which columns are available so that they can only pick from these columns. So you can do that if you want. Just add another function to data storage that tells you the different columns in the header, display them to the user in the menu, and allow them to pick from one of them. As usual, if you have any questions about the implementation, you can join our Discord server and we'll be more than happy to have a chat with you and help you out if you have any questions. Alright, thanks for watching, hope you enjoyed it, I'll see you tomorrow.